Alright, so we're going to look at this use of the fundamental theorem. And what we're going to do is we're going to look at the first definition of the fundamental theorem. I'm trying to find a page number for everyone here. We're looking at page... Again, I know this is a little hard on the electronic book. We're going to look at the fundamental theorem part 1. And the fundamental theorem part 1 says that f prime of x equals d dx of a to x f of t dt, and that is equivalent to f of x. And we're going to note some things about what we're given here. So we're asking for dy dx, which is f prime of the antiderivative. So we're going to do dy dx of this is the same as going to be taking the derivative of this. And the note that we have here, sorry, that's an x up there as I'm tracing around, accidentally scraped on it here, is that we have some constant to the x value. So if we're going to look at what we're given, we're going to want to do some rearranging here. So dy dx is going to be d dx of root x to pi cosine t squared dt. And then I'm going to do d dx, and I'm going to pull a negative sign out front because I'm going to use our theorem where if we switch the order of our integration, it takes the negative of everything. And then I have to make this just a plain x, which I have in my theorem. So I'm going to do a variable switch over here. I'm going to say that u is equal to x to the 1/2, or square root of x. So du is 1/2 x to the negative 1/2 dx. And I'm going to rewrite this in the form of du dx is equal to 1/2 x to the negative 1/2, because this form will work with a chain rule for me here. And so now what I can say is dy dx is equal to dy du dx as for my chain rule. And if I rewrite this as negative d du of pi to u of cosine, I'm going to have to think about this thing here in my weird little substitution world that I live in. And so I have to look at this as being, well, this is going to take my u anywhere. So we'll keep t squared dt. So now I have dy du, and my chain rule says I have to multiply that by du dx. Now this is in the form that I started with. It's going to have the negative sign out here, and this is going to become cosine u squared, right? Because I have d du of this stuff. This becomes cosine u squared, and then I'm going to multiply it by du dx. And with a variable substitution, u was x to the 1/2. So this is going to be negative cosine x times 1/2 or 1 to root x. So I'm bringing this down here. And all said and done, it looks like this. And we have our solution using the first part of the fundamental theorem.